Let's look at practice exercise 16.21, which is surroundWith. We're going to write a method called surroundWith, and it's taking two integers, x and y, as its parameter, and it's going to surround all nodes in the list containing the value x with new nodes containing the value y. In particular, each node that contains the value x as data should have a new node just before it and after it as well. If no nodes in the list contain x, then the list should not be modified, and then we have this example right here. Let's look at this first one. So we have 0, 1, 2, 1. We have list1.surround with 1 and 4. So all the ones inside of this list should be surrounded with 4s, and we can see that clearly right here. We can assume we're adding this method into our LinkedList class. Let's start coding with it. It's going to be a public void because it's just modifying, not returning anything. It's called surroundWith. We have int x as well as int y inside of here as parameters, and now we can start coding. Inside of here, we want to make sure that our front isn't null, otherwise there's no use of doing anything. So if this dot front does not equal to null, we can be inside of this if statement, which is going to be encasing our entire code along with this method, and that's going to be pretty much it for the skeleton of the exterior part. Now inside of this, we're going to have two separate conditions, one if it's at the very front, and then one if it's at the rest of our list or at the end. We're going to handle this separately. If it's at the front, we'll start with that one. We'll say front here. Well, first, before we do this, we want to make a new list node, and we're going to call this current, and we're going to set it equal to this dot front. That way we can traverse through our entire list without modifying it and losing our head. Well, we want to modify it, but we just don't want to lose the initial starting point. Otherwise, we lose our whole list. For the front, we're going to have an if statement. And we're going to say if this dot front dot data is equal to our x value, then we are going to want to surround it. So if it's the same thing, we're going to first store the head. That way we can't lose it. Essentially, we're doing this, but inside of here. We're going to say list node, and we'll call this temp. And we're going to set it equal to this dot front again so we don't lose the head. Now we need to make y, the variable y here, we need to make it a new head. So we're going to say this dot front is equal to, we want a new list node in here that's going to be our y. So we're going to do new list node, and then we are going to have y passed in. So essentially what we're doing is we're saying this dot front, which is the pointer to the front here, is equal to a new list node. And we're essentially creating a new value spot, and we're passing in the value, the data value, y. That's pretty much how that's going to work. And then after this, y is our new front. So we would basically, if it started at the very beginning, let's just say 0 is what we want to put in, 0 is our front. Now we have to append the rest of the list to that. So we're going to do this dot front dot next is equal to, and then we're just going to have our temp, because remember it stored the previous front and everything after that. Now that's all great if we want to surround the first one. Like let's say we wanted to surround this 0 with, let's say, 5s. So we have a 5 here, we'd have a 0, and then we have the rest of our list. We want another 5 right here, don't we? So we're going to have to do that next. We're going to do that right here. What we essentially want to do is we want to examine the next value, because if we have a 5 in here and then we have our 0, this is the current value, this is our next value, and this is the next value. We want to take the next value and store it in a temporary node so we don't lose it. So let's update our temp. We're going to set temp equal to this dot front dot next, and again that's essentially putting everything, all of this, we're storing it so we don't lose any of it. Now we need to make a new list node to add our y in again, and that's going to be in the, you guessed it, the next value. How we're going to do this is set this dot front dot next equal to a new list node where we pass in y. Pretty similar to the first one. After we do this, we are just going to want to append the list again to it, because now we have 5 inside of here. So that's going to be the next value. Let's just copy this, we don't have to type all that out again, is now equal to our temp value. And that's going to put the rest of the list back behind it. And so that's pretty much going to be it. Then we're going to have 1, 2, 1, and then we're going to want to start examining everything past here. So we're going to want to update this previous current value once we get out of this if statement. So at the end, the very end of this if statement, we want to be at this value, right? That's the current dot next, next, next. So we have 3 nexts. So all we need to do, I'll just copy all of this in here, is take our current and set it equal to our front, this dot front, and then we have dot next, dot next, dot next. And that's going to move it into the correct position. Again, that is for our front. It's going to close that if statement, and now we can do our middle to end. And this is going to be in a while loop. And we're going to want to run this while our current is not equal to null, because if our current value is null, then we're at the end of our list. Or the reason why we were looking at the front specifically for this one is because all the next ones that we're going to look at is the next value. So if we're currently looking at this 1 right now, we're not looking at the 1, we're actually going to be looking at this next spot. So actually, if I'm thinking about it, we have a 5, 0, 5. We should examine this 1 right here. So instead of having a next, 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 we should have this dot next dot next. So the current pointer should be pointing at this 5, because this is our front. So we should set our current value equal to next, next, and not 3 next. That way we'll stop at this 5 right here, so we can examine everything past that. Because again, in this while loop, middle to end, we're going to be looking at the next value. So let's get rid of this right here, and we'll say current is not equal to null, and current dot next is not equal to null. So inside of here is where we're going to do the check if our current dot next dot data is equal to x. Notice how I said the next, so we're looking at the next value. We're going to want to be inside of here. Otherwise, we're just going to want to skip to the next value. So we'll say else, and then inside of this else statement, all you need is a current is equal to current dot next, and we're essentially just moving our pointer down the line. And that's pretty much going to be it for that else. Let's close off our while loop, and then that's the else statement, close off the while loop. And now we can code inside of this while loop if we have our current.next.data is equal to x. So let's pretend that we're looking at this right here. And let's say that we're looking at 0 currently. That's where our current is pointing. And we want our 1 to be x, and then we'll just replace it with, like, we'll just say 3. And so current.next.data is equal to x. Well, current.data.next is equal to x. So what we're going to want to do is place a value in before this. What we're going to want to do is store the rest of this list beforehand so we don't lose it. That means we are going to have to make a temporary list node. List node temp is back, and he's going to be equal to, like I said, our current dot next. So once that is done, we've stored our list. We can now add a value y to the next value in our list. That's going to be the next data. That's what we want to be adding in. So we're going to set our current dot next equal to a new list node. This is the only way we can add data in. New list node y, and that essentially makes a new node here with a next pointer, and it stores in our data value, which is this 3. And then after this, we want to add our value and the rest of the list for that matter back in. So we're just going to set our current dot next equal to temp, and that basically puts our whole list back together with our new list node added in. So now we have this 3 in here, but we want a 3 behind here as well, right? So what we're going to have to do is move our current pointer over to 2. So we're just going to set our current equal to current.next.next. And essentially what we're doing is we're moving this pointer past this 3 and then to this 1 so we can have the next value. And the process is gonna be basically the same thing. So let's copy all of this, and I'll tell you if anything changes. We're gonna paste this down here, and we'll move this one over. Actually, we have to take out this entire part because temp already exists. So we're just updating it. Essentially, temp is going to be equal to our current.next, which is just going to be this 2, 1, and whatever else we want to store. That's going to be right here. Temp is equal to all of that. And then current.next is going to be this new list node 3. It's going to be added in. Perfect, perfect. And then our current.next, so past this 3 is going to be our temp value, because that's the spot we want to add in. So once this 3 is added in, our list is now complete. We have our new list node, we have our temp added in, and then all we got to do is move our current pointer over so we can pass this 3. So current is going to equal to next, which is going to be this 2 right here. But then we kind of skip over that 2. So let's actually make this a current is equal to current.next. And that'll pass 4 to 4 tests. You know, now that I'm doing it, just between you and me, you can see that these 2 lines are the same. And if they're the same, we can actually take this out and also take out this else statement, which means this current is equal to current.next is gonna run no matter what, no matter if we go into this if statement or if we don't, because we need to move to the next value anyways. And that's gonna be it. 4 to 4 test pass. That is our practice exercise 16.21, surround with. That is the code. And that's how I would do it. If you have any questions, as always, leave them in the comments below. If you want more practices, check that description out in the playlist. You have tons of them. I think like over 600. So have fun with that.